Okay, so, oh, let me go back, sorry. So chapter 4 is all about solving equations, all types of equations. Power equations, quadratic equations, just polynomials in general. Um, so one of the things I just want you to realize, solutions, roots, and zeros are all the same thing. The roots of a polynomial, the zeros are the polynomial, are just the answers that make it true. Okay, they're both, all three of these words, solutions, roots, zeros, all make the equation true. All right, so we know that if x squared equals a number, so let me just make this super easy. So say that x squared equals 4. In order to solve for x, we take the square root of the equation, and you always need plus or minus if it's an even root. Like square root, we always need plus or minus. So notice how they state this definition. If k is something other than 0, anything other than 0, you just do the plus or minus square root of the number. They specify that x equals 0 if k is 0 because there's only one solution. There is no plus or minus 0, it's just 0. And if k is less than 0, we don't have real numbers, those are imaginary. Remember when we take the square root of a negative, that's an imaginary number. IB pretty much just deals with real solutions, so we won't have to worry too much about that. All right, so for example 1, if you only see a single x in the equation, isolate the x. Add 1, divide by 3, x squared equals 3. So we square root both sides, so we need plus or minus, and we can't take the square root of 3, so it just stays the square root of 3. For letter B, subtract 5, divide by negative 2. Here's where they're checking to see if you're on top of your game. Because I'm square rooting a negative, there are no real solutions. Okay? When you have a quantity squared, you treat this no differently. We're trying to get to x to get it by itself. So first we need to get rid of the square, so I take the square root first. Then I'm left with x plus 3 on the left, plus or minus 6. Then when I subtract 3, be very careful here. Technically, we have 3 plus 6, and we have negative 3 minus 6. This plus or minus 6 means that we have both a positive and a negative 6. So we have 3 and negative 9. It's always nice if this number is not a real number because you just really tuck it in front of the plus or minus. But if this is a real number, you've got to simplify that down. Let me show you what I mean here. When we square root both sides, I get x minus 4 on the left equals plus or minus, and I can't take the square root of 7. So when I add 4 to the, I have 2 equal signs. When I add 4 to the other side, we just have 4 plus or minus the square root of 7. And you can just leave it like that. So it's always nice when this is a radical because it's simpler. Letter B then is looking at all the other roots. Where A is the square roots, then this is everything else. All right, so first of all, a power equation is just where x is in the exponent, or x is the base, and a number is in the exponent. So any power of x is a power equation. So to counteract all power x's, you just take the root of the power. And if it is even, we follow the same rules as squares. If it is odd, it's just that root. There is no plus or minus. It's either going to be a positive number or a negative number. It will not be both. You only need the plus or minus if it is even. Okay, so here you just want to isolate the x and then use the root to match. I'm going to write this out. So you just match the root to the power. So if this is the cube power, you then just take the cube root of both sides to cancel that out. So the cube root of negative 27 is negative 3 because it takes us 3 negative 3's to get negative 27. So when we do the cube root, it's how many, I need 3 of what number to get negative 27. All right, letter B, we first have to get x to the 4th by itself. Then I'm going to 4th root to counteract the 4th power, both sides. And as soon as I take an even root, I need plus or minus square root of 10. Here we just need to counteract the power first. So we'll take the 5th root of both sides. And since it's odd, I do not need the plus or minus. It's just the 5th root of 11, which we cannot break down. When I add 2 to both sides, be careful. It's 2 plus the 5th root of 11. There's no plus or minus there, so we have to put that plus in between. We're adding 2 to the 5th root of 11. And you could have put the 5th root of 11 plus 2. Typically, though, when you have a radical, the radical is the end of the equation because you don't want to, if you have sloppy writing, you don't want to look like you put that plus 2 underneath the radical with the 11. We always just end with the radical. And that's it.